Hello everyone. Welcome back to week 3 of the BLOCKOCAST competition. This is Dakshan of first year CSE department, Sri Venkateswara College of Technology. And today the topic we are going to see is the challenges in blockchain scalability. One of the major challenges associated with blockchain is scalability. The ever increasing demand for blockchain applications has resulted in significant scalability challenges, resulting in transaction latency, making the system slower and less efficient, thereby hindering their widespread adoption and utility. As blockchain adoption continues to surge, the issue of scalability looms large. Therefore, to address these challenges in order to be able to handle a large number of transactions and have more efficient performance, the blockchain industry has been actively working on solutions to address these blockchain scalability concerns. In this video, we'll dwell into the various challenges associated with blockchain scalability problems and examine the various blockchain scalability solutions, exploring their fundamental concepts, benefits, and real world implications to address these issues while maintaining the network security and decentralization. What is blockchain scalability? When discussing scalability in the context of blockchain technology, the term refers to the transaction processing speed. The blockchain scalability has to do with the capacity of a blockchain network to handle a growing volume of transactions, store data, and increasing the number of nodes running the blockchain network efficiently and in a timely manner without compromising on its core features such as security, decentralization, and consensus. For a blockchain network to meet up to its expectations, it must be able to process loads of transactions per second. Some factors which can impact blockchain scalability are networking, cost and capacity, finality, throughput, and confirmation time. The ability of a computer system to handle an increasing volume of work is referred to as scalability. With a large amount of data, a blockchain network does not scale properly or has low scalability. Blockchain does not make significant measures to modify the system to deal with expanding demand, data, and resources. Talking about scalability, it has a variety of significance in case of the blockchain technology. For instance, to upgrade Bitcoin with reference to the feature of throughput, bootstrap time, latency, cost per transaction, is referred to as increasing the scalability of the Bitcoin network. Although their throughputs are substantially different, multiple blockchain networks can be called scalable. It is crucial to understand that the term scalable is a contrasting term in blockchain technology. When a blockchain platform is said to be scalable, it achieves a great transaction per second than any other current system by changing or evolving its consensus methods and adjusting specific system characteristics. Why is scalability in blockchain important? The importance of scalability cannot be underestimated. Scalability is a critical factor in blockchain network since the network size and complexity increase with each transaction added to the blockchain. It is pivotal that blockchain networks are able to process loads of transactions very quickly and effectively to meet the increasing demand. When a certain network is not capable of handling the transaction demand or requirements, it will result in a slow transaction processing time, which results in high fees and poor user experience. Slow transaction times and high transaction fees may hinder the usability and practicality of blockchain networks, especially for applications that require high transaction volumes, such as decentralized finance, supply chain management, and others. As a result, scalability is critical for blockchain's future growth. Scalability in the blockchain is about the network's capacity to process a large amount of transaction throughput, and it is the fundamental criterion in minimizing network downtime. The increased use cases and adoption of blockchain technology cannot affect the performance of a highly scalable blockchain platform. Blockchain platforms with lower performance and clogged networks have low scalability due to high data being processed on them. Talking about the blockchain trilemma with reference to the scalability factor suggests that we will have to compromise on security and level of decentralization to achieve higher scalability. On the same note, it is important for us to remember that these platforms are competing with traditional centralized platforms which are way faster than the blockchain platforms. Scalability challenges. Scalability has been identified as the most significant barrier to establishing public blockchain. Blockchain scalability problems basically refer to the challenges in the blockchain network. These challenges include limited throughput, high fees, and long confirmation time. One of the primary limitations of many popular blockchain is the limited transaction throughput and latency in processing transaction promptly. Scalability issues can arise when a blockchain network is unable to process a sufficient number of transactions when there is a significant increase in the number of transactions, inversely proportional, leading to slower confirmation and processing time and higher fees. They are also inversely proportional. Traditional blockchains like Bitcoin and Ethereum are facing inherent scalability limitations due to their design choices. These networks typically rely on consensus mechanisms that require every participant to validate and store all transactions. The scalability issues emerges mostly when the number of nodes and transactions increases. While this ensures decentralization and security, it comes at the cost of limited transaction throughput. These blockchains thereby experience congestion, resulting in delays in transaction confirmation and inflated transaction fees. Bitcoin is facing scalability issues due to its limited block size that restricts the number of transactions that can be included in a single block, with block creation time averaging 10 minutes and block size limited to 1 megabyte. The current capacity of the Bitcoin blockchain can only process around 7 to 10 transactions per second, far less than traditional payment systems like Visa, MasterCard, Amex, RuPay, which can handle thousands of transactions per second. Blockchain networks face a fundamental challenge known as the scalability or blockchain trilemma. It refers to the idea that it is challenging to simultaneously achieve three key features of a blockchain system, which is decentralization, security, and scalability, thus requiring trade-off to improve scalability. The trilemma suggests that obtaining increased scalability would come at the expense of decreased security and decentralization. At the same time, it is critical to remember that only scalability can enable blockchain networks to compete successfully with the traditional centralized platform. This trilemma highlights the need to finding the right balance between these three critical aspects of blockchain technology being essential for blockchain's growth. To address the blockchain trilemma and other issues mentioned above, researchers and developers are exploring various solutions to increase scalability, whereby a perfectly decentralized, secure, and scalable blockchain is the ultimate goal. But is it feasible to create blockchain scaling solution without compromising security or decentralization? We'll show that in the following part. Solution to the scalability problems. The need for scalable blockchain networks has spurred the exploration and development of numerous solutions and practices to help overcome the scalability challenges, including the limitation of transaction throughput and high fees. These solutions aim to increase blockchain networks, transaction throughput, and capacity while maintaining the security and decentralization that make blockchain technology so valuable. Scalability advancements are consistently made across the various blockchain networks. Blockchain scaling solutions have been developed in many forms. These can broadly be categorized into four categories, including Layer 1 on chain solution, Layer 2 off chain solution, 3 scalable consensus method, and fourth one hybrid solution. Each solution category provides distinct strategies for addressing the blockchain scalability issues. Each approach tackles scalability differently, and their implementation varies depending on the blockchain's network's architecture. In addition to these proposed solutions, other blockchain networks are exploring various innovative approaches to address scalability issues. Layer 1 on chain scalability solution. This is the most common blockchain scalability solution, also known as first layer or on chain scaling solution. It is used to modify the core architecture of the blockchain. Layer 1 solution aims to address scalability challenges by making optimizing changes to the underlying protocol itself to increase its transaction throughput. Segregative witness, SegWit, sharding, and hard forking are the three prevalent layer 1 blockchain scaling options. SegWit. To address these scalability issues, Bitcoin developers proposed a solution called SegWit. SegWit is a protocol upgrade that focuses on changing the way and structure of data storage. The solution is designed to primarily enhance transaction throughput on a blockchain by changing how data is stored, making blocks on the network smaller, resulting in increased capacity and storage space for transactions within Bitcoin's 1 MB storage blocks. It separates transaction signature data from the transaction data, thereby enhancing scalability, making the network more efficient. The removal of the digital signature may free up additional space for the addition of new transactions, allowing more transactions to be processed in each block, thereby improving Bitcoin's transactions efficiency and capacity. However, it has its disadvantages also. While it enhances throughput and capacity, it isn't a comprehensive long-term solution to blockchain scalability. Sharding. Another popular on-chain scalability solution is sharding, introduced by Ethereum to improve the scalability of its blockchain. It involves the breaking down of the blockchain network into smaller, more manageable datasets known as shards. By breaking down transaction into smaller pieces, it can act as a sum of its parts, with each shard handling a portion of the group's transaction processing. Sharding effectively eliminates the need to rely on the performance on individual nodes to achieve quicker and more efficient transaction throughput. Each shard operates independently, processing its own transaction and smart contracts. Each shard is thereby managed by specific nodes, allowing multiple transactions to occur simultaneously. The network would then execute the shards in parallel with one another. As a result, sharding can significantly save both storage space and processing transaction time, thereby increasing the overall transaction throughput and capacity of the overall network. On the other hand, it can also present challenges related to security and communication between shards. Hard forks. And there is the hard fork, a procedure that focuses on making structural or fundamental changes to a blockchain network properties. Hard forking may increase the size of the block or reduce the time necessary to create a block. While hard forking is a prerequisite for layer 1 blockchain scalability solution, a contentious hard fork is the most productive option. This essentially suggests a split in the larger blockchain networks with a certain segment of the community contradicting the core community on specific topics. In such instances, a subset of a blockchain community may elect to make fundamental modifications to the underlying source. Layer 2, off-chain scalability solutions. The viability of first layer or on-chain scaling method is heavily dependent on changes to the main blockchain network. There is now a wide variety of layer 2 or second layer scalability solutions to choose from that have drastically reduced transaction time. Layer 2 solutions aim to address scalability challenges by building additional layers on top of the existing blockchain network without making fundamental changes to the underlying product. The secondary protocols would be used to offload transactions off chain and periodically setting them on chain in order to increase its capacity, which can reduce congestion and increase transaction throughput. These layers can include state channels or side chains and protocols such as Lightning Network and Plasma, which enables instant and low-cost transactions for users. These solutions have demonstrated significant promise in improving the scalability of blockchain technology, thereby increasing its usability in various industries. Layer 2 solutions have the potential to transform finance, supply chain management, and digital identity verification, among others. Sidechains. Sidechains are a popular choice among layer 2 solutions for determining how to solve a scalability issue in the blockchain of your choosing. They are separate chains that are connected to and run in parallel with the main blockchain. They operate as a transactional chain next to the blockchain in big batch transactions, enabling the processing of transactions of the main chain in a more efficient way. Sidechains can provide faster transaction confirmation and lower fees as they are not limited by the transaction throughput of the main chain. This approach reduces network congestion on the main chain, enhancing scalability. In comparison to the primary chain, sidechains use distinct consensus techniques that can have different rules and functionalities tailored to specific use cases. State channels. State channels are a typical inclusion among layer 2 solutions for blockchain scalability. They allow two-way interaction between blockchain network and off-chain transaction channels through various approaches. They enable off-chain transaction between users without having to interact with the main blockchain for each transaction. On the other hand, state channels function as a resource layer to the network that is integrated with the assistance of a smart contract or multi-signature method. State channels have the potential to significantly improve the capacity and the transaction throughout speed of the blockchain network to a great extent by creating a secure channel. Participants can engage in fast and inexpensive transactions. This technique can significantly reduce congestion and minimize transaction fees, making it ideal for high frequency, low value transactions such as microtransactions and gaming applications. Nested blockchain. At its core, this solution operates as a decentralized network infrastructure that utilizes the main blockchain to establish parameters for a wider interconnected network of secondary chains. It guarantees the execution of transactions across a network of interconnected secondary chains by allowing transactions to be executed over the secondary chains. Nested blockchains can improve scalability without impacting the main blockchain's security or decentralization. Payment channels. Payment channels facilitate off-chain transactions between parties conducted in parallel to the main blockchain. These channels are established, transaction executed, and channels closed with final state recorded on the main blockchain. Payment channels allow for faster, cheaper, and more efficient transactions by conducting them off the main blockchain. By establishing a direct payment channel between two parties, transaction can occur rapidly with minimum fees. Lightning Network and Raiden Network are notable implementations. Lightning Network is used in Bitcoin. Lightning Network, one popular layer 2 solution, which is a payment channel network built on top of the Bitcoin blockchain. The Lightning Network is an off-chain protocol that enables instant, low-cost transaction by establishing payment channels between users. Transactions can be routed through these channels without requiring confirmation on the main blockchain. They can conduct multiple transactions off-chain and then settle the final transaction on the main blockchain. The network thereby exploits smart contract functionality through these private off-chain channels over the main blockchain network. Plasma. Another prominent blockchain layer to scalability solution is Plasma, which is a scaling framework for Ethereum. It primarily focuses on the use of child chains that come from a parent blockchain. Each of the child chains functions as a separate blockchain that operate independently and conduct transactions of the main Ethereum chain. Plasma may be created for use cases involving processing a certain type of transactions while assuring execution in a comparable environment with enhanced security. Hybrid solution. There are various blockchain scalability solutions that involve combination of the both above approaches, so-called hybrid solutions. A blockchain might use both sharding and layer 2 solution to increase transaction throughput whilst also optimizing its protocol for better performance. A great example is the core DAO network that tackles the scalability problem by leveraging the Satoshi plus consensus mechanism, which combines the best aspects of Bitcoin security and immutability. Proof of work and Ethereum scalability and efficiency (DPoS). This innovative approach allows the protocol to provide a robust layer 1 blockchain solution capable of handling a significantly higher transaction volume while maintaining security and decentralization. This provides a promising framework for building scalable D apps and unlocking the true potential of blockchain scalability. Inter-blockchain communication issue. In a landscape with numerous coexisting blockchains, seamless interaction and interoperability is also a great challenge. There are various cross-chain interoperability solutions that aim to connect different blockchain networks, allowing for a seamless exchange of value and data. This may help increase the overall capacity of the blockchain ecosystem by allowing different networks to work together, thereby contributing to the alleviation of scalability concerns. Protocols like Polkadot, Cosmos, and other interoperable blockchain networks enable seamless integration and communication and the efficient transfer of assets and data across disparate blockchains. This interoperability enhances scalability and opens up a world of possibilities for developers and users to leverage the strength of multiple blockchains. Looking ahead, blockchain scalability is a critical factor that needs to be addressed for blockchain technology to reach its full potential and deliver on its promise of secure, decentralized, and efficient transactions. Balancing scalability, decentralization, and security, thereby remaining a critical challenge. However, these are not insurmountable obstacles. In the meantime, various solutions have been proposed, offering a promising path forward to overcome the scalability limitations of layer 1 blockchains. There is, however, no one-size-fits-all solution to the blockchain scalability problem, and none of them are yet perfect and each has its limitations. Looking ahead, the future of blockchain scalability is promising, with further advances expected in scalability solutions. As blockchain technology continues to evolve, the balance between security, decentralization, and scalability will continue to be refined, propelling us towards a scalable and decentralized future, thereby driving the mainstream adoption of blockchain across various industries. For businesses and organizations, it is therefore important to stay informed on these developments and be proactive about adapting to the changing landscape of blockchain technology. Thank you. guys for staying till the end. Hope you guys got a clear-cut understanding of the scalability problems in blockchain. And sorry if there is any audio issues in this video. I'm not at my home right now. See you guys in another video. Until then, goodbye.